Yeah, currently in Magma master branch in GitHub, the 5G code is committed for the following features: the registration and deregistration of the UE, and then PD session establishment and release, then idle mode support and paging, and then as such, the authentication code of 4G is extended and 5G basic authentication is supported now. And the code is available for experimentation. And in case you need any help as part of the support activity, you can reach out to the Slack channel of Magma. And yeah, towards the end, after the demo, you'll have information about how to reach this support channel.
Thank you.
Kader, can we go to the next one?
Yeah.
So the brief demo scenario is here, and the AGW in the middle, the architectural approach that Magma has adopted. Phil has given a detailed account of it. The elegance of Magma you can observe in the XAP XNAS, means the access protocol, whether it is S1AP of 4G or NGAP of 5G. So that is the application protocol for the access side, and then the NAS, 4G NAS and 5G NAS termination happen in the front. And in Magma today, the daemon is named MME. Eventually, that is going to be renamed to access daemon. This is the only generation-specific network function we have in the 5G or 4G core together in the converged core system. Except for this, all other network functions that are showing up in red color, these are all generation neutral, and Magma have evolved them with an optimized approach. In some other conferences, we have given how Magma differentiates from the 3GPP and what are the optimizations that Magma community have brought in. You can browse through those videos on the YouTube. The subscriber DB handles the addition of the subscribers, and then the QoS policies are part of the policy DB. Session D handles the equivalent of SMF functionality. Of course, it will also handle the 4G related session management. And pipeline D is the control function of the first path. And the orchestrator is going to configure the subscribers on the subscriber DB. And the N1 and N2 procedures today that are part of the demonstration are NG setup, the N2 procedure, and then the UE registration, video session establishment, idle mode, support, and paging. If time permits, we'll demonstrate. Otherwise, we'll skip that and directly dive on to video session release and UE deregistration. With that, I hand over the control to Yogesh and Parthiban to take us into the demo scenarios.
Sure.
It will be a live demo.
Thanks, Suresh. Before Yogesh and Parthiban takes over, I just wanted to mention a couple of things. As you know, one of the objectives of this meeting is to really enable the support to the communities, both the third-party communities as well as the vendor and operators community who wants to get support from Magma 5G community. So what we have done is in our Slack channel, we have created a channel, separate channel where you can come in and ask your questions. We'll be happy to support you to do, whether it is a demo or integration with your equipments and so on. We'll be glad to support from the Magma community. And the second thing that I also would like to say here is that we have a Magma orchestrator deployed in AWS, so you don't have to really do the heavy lifting. If you wanted to really test Magma Access Gateway, you can deploy it in any of the hardware that you choose to, right? Commercial off-the-shelf hardwares or AWS Outpost or any other hardware. And reach out to us in the support channel. We'll be happy to get you hooked up to the orchestrator that's available in AWS to have you get started with your trial run and experiment and so on. I also would like to thank here Rebecca, who has really helped us with their 5G simulators to do some initial testings in this deployment, so we are able to better support the community as well as thanks to Wave Labs for the orchestrator that's made available to the community for support and test of 5G access gateway. So with that, I would like to hand over again back to you, Suresh, and your team to show the demo, please.
Yes, Kaza, thanks. Yeah, Yogesh and Padman, without loss of time, let's dive on to the demo.
Yeah. So, Suresh, thanks. Maybe Padman, I can just show the demo use case and then start from there. Yeah, so Padman, are you able to see my slide?
Yes, go ahead, Yogesh.
Sure, thanks. Hello, everyone. So this is just a layout of the demo environment. Here we are having the orchestrator, which is there in AWS, and that is connected to the AGW, where the Magma services are running. And we have a GNV and the UE simulator, which is going to connect to the AGW register and then finally establishing the video and connecting to the DNN for sending the traffic. So this is the layout. Rupa, can you please share your screen for the demo?
Yogesh, can you stop your screen sharing?
Sure. Over to you, Rupa.
Yeah. So, yeah, good. We are able to see the terminal here now. So hello, everybody. So Rupa, you have listed down the list of subscribers available right now on the Access Gateway. So this is a couple of subscribers we have added right now for the testing purpose. We will be adding a new subscriber right now through the orchestrator, which is available on our AWS cloud. Yeah, we can move to the NMS dashboard. Yeah. We'll be adding a new subscriber here, and we will be able to initiate a UE call, the registration call, the 5G registration call. So we will be adding the IMSI details with the authentication key and the OPC values. Yes, we will be able to see that now. Save and add subscriber. Yeah, we could see that successfully this subscriber is added here. We could see that this is the last entry available here. Yeah, we can go back to the AGW subscriber CLI. We can list it now. We'll be able to see that, yeah, we can see the second entry on the list. We have been able to add the subscriber here now. We are able to see it in the subscriber DB. Yeah. Yeah, Rupa, move to the multi-screen. We could get started with the UE registration.
Yeah. So I think setting up the Wireshark to have the live captures of the registration and the traffic. Yeah. Just giving a brief on the windows here. The top left window, it is at the and the right window, it is the incoming and the outgoing tables, which is part of the OVS. So all the packets, uplink and downlink, they are going to land on table 0, and the packet will be put on the wire table 20. And on the down windows, the bottommost right, this is the GNB simulator, which is going to connect to the Magma 5G core. And on the bottommost left, we have the UE simulator, which is going to register and send the traffic using the Magma core. So Rupa, I think we can start with the GMB connection. Yeah. As we can see, the NG setup is up. The GNB is connected to 5G core, and we are good to register our UE and send some traffic. Rupa, we can start our UE simulator. Yeah, so we have done the UE simulator. The UE is registered, and we can see the video session is also established. On the OVS table 0, we can see the OVS table is populated with the entries to handle the traffic. The first entry is for the uplink traffic. So this is where the uplink traffic will come with the tunnel ID. In this case, it is some big number, we can say. And so here the packet will come and all the QoS policies will be applied. The GTP packet header will be stripped off and will put on the wire. And the second entry is for the downlink, the traffic which is coming from the internet, basically targeted for the UE. Here we have the UE IP as 192.168.128.21. So we can see our table 0 is ready to serve the UE. Rupa, can we start sharing the sending the traffic because the PD is already established? Yeah. So we are sending the simple ICMP packet, and we can see the packets are sent and sealed. It's successful. We can also see the packet counters that's getting incremented in the first entry. I think I think there is some display issue. Yeah, it's taking some time. Yeah, so basically we have sent 10 packets, and you can see the 10 packets are sent and 10 packets are received, both in the uplink and the downlink direction, as this is the incoming table. And then moving on to the outgoing table, I think, yeah, it's still loading. Yeah, maybe there is a delay. But the idea is to show that yeah, the packet is actually put on the wire in both the directions. Yeah, no problem, Rupa. I think we can show the PCAPs. Maybe we can, or you. Yeah, or yeah. So this is the PCAP where we can see the registration request going through. And we can see that there are some sync failure, but that is recovered, and we have sent the authentication back again. And after the security mode complete, the uplink and the downlink packets are sent with the GTP header. So this is the signaling part, and then we have the request and the response part. And yeah, you can see all the packets here. Yeah, Rupa, I think shall we do a session release and deregister? Yeah, so here we have done the session release. The video session is released. So we can see the video has been, the session has been released successfully. Okay, yeah, I think the window is taking some time to load. Yeah, I think we can start the deregistration procedure. Yeah, and now the deregistration is successful. The UE has been successfully deregistered, and all the OVS tables which were present, the additional entries for handling the traffic is being removed. Whatever is left over is the default entries which are present. Yeah, Rupa, maybe I think we can just go back to the PCAP and just see the packets for, yeah. So here we have, after the traffic has been sent, we can see the video release message, the video session release message, and then in somewhere in the down, Rupa, I think we can go to the down and we can focus on the deregistration. Yeah, so here we have both the video session release and the deregistration happening. Yeah, so I think I would say this was our demo. I think for idle mode and paging, it will take some more time. So I think we will just stop here.
Yeah, thank you, Yogesh. Thanks.